Yesterday we spent time translating equations from words into the algebraic equations. Today we're going to look at our introduction to solving equations. And yes, we've solved equations before, but we're going to go through this one step at a time, and we're going to start with the one step. To solve an equation means that we're going to find the value of the variable that makes that equation true. So we're going to isolate the variable using one inverse operation. We're going to look at equations and we're going to recognize or identify what operation is being performed and then do the opposite or inverse. So we're going to look at some subtraction equations here where we will be adding to isolate the variable. Let's start with the first one. Again, c minus 22 equals 54. The inverse of subtraction is addition, so I'm adding 22 to both sides. I get c is equal to 76. Again, a simple check will make us sure that we have the correct answer. 76 minus 22, when I subtract, I get 54. It works. Let's look at the one on the right. Negative 12 plus x equals 35. Well, if I have to eliminate what's around this variable, and I have a negative 12, that means I'm going to add 12 to both sides. X is equal to 47. Now again, if I take a negative 12 plus 47, and the signs are opposite, so I subtract and keep the sign of the greater absolute value, I am going to get 35. My next one says that I should be adding 25. So go ahead and add 25 to this next problem. Let's see how you did. Adding 25, that isolates my variable. This cancels out and x is by itself. I'm going to add, and I get 138 is equal to x. I'll do something called interchange, where I put my variable first. I get x is equal to 138. Next one, x minus 15. I see subtraction, so I'll add 15 to both sides. Once again, x is equal to 38. And we could do a check on every single problem. We are going to encounter the ones with signs, so here we're going to be adding 87 to both sides. Still adding one inverse operation. Y is now isolated because additive inverses are equal to 0. My signs are unlike, so I need to subtract and keep the sign of the greater absolute value, which is positive. So we used what we called our addition property of equality because we added the same number to both sides. Now let's look at the inverse. We're going to be subtracting because the inverse of addition is subtraction. So once again, I have a positive 63. 63 plus m. I'm going to subtract 63 on both sides. Additive inverses cancel out. I'm left with m, which was my goal, to isolate my variable, and then all I need to do is subtract. If I plug that back in and I see 63 plus 16, if I add this up, I get 79 and it checks. Whatever I see, I do the inverse. I have a positive 27. If I subtract it, it will cancel out. So whatever I do on the left, I do on the right. It's called the property of equality. And this one was a mental math because 27 plus 3 is 30, and you probably knew that without having to do the math. Sometimes my variable will be on the right. I'm still going to inverse and subtract on both sides. Here's where I need to be careful because the rules of subtraction tell us to add the opposite. So now I have negative 12 plus negative 16, and that's negative 28 is equal to p. Interchange and write your variable first, and there's your answer. On questions like that, I think it's important to do the check. 28 plus 16, Signs are unlike. You subtract and keep the sign of the greater absolute value, negative 12, and that's where it all started. Last one, subtract 7 on both sides. Again, the rule is to add the opposite. So I have 5 plus a negative 7. 5 plus negative 7, unlike signs, subtract, keep the sign of the greater absolute value. We did inverse operations with adding and subtracting. Now let's look at a couple more. In this next problem, you're going to see a multiplication. 4 times x is 20. So the inverse of multiplication is division. Let's divide both sides by 4. And negative 20 divided by 4 is negative 5. Should we check? Yes. 4 times a negative 5 multiplied together gives me negative 20. It checks. Once again, this is a multiplication, so I'm going to divide both sides by negative 6. Cross cancel here, and I get negative divided by negative is a positive, and I get x is equal to 7. So again, one inverse operation helps me to get my answer. This last one is multiplied by a fraction, so my coefficient is a fraction, and in a case like this, I multiply by its reciprocal. Multiplying by a reciprocal cancels out because any number times its reciprocal is equal to 1. I then cross cancel here, and I get 6 times 3, which is 18. So these all were multiplication problems, so I did the inverse and I divided. One more one like that. When my coefficient is a fraction, I'm going to multiply by the reciprocal. By multiplying by the reciprocal, it cancels out to isolate x. Whatever I do on the left, I do on the right. Since I can't simplify, I'm just going to multiply my numerators and multiply my denominators, and there's my answer. All right, so if there's a fraction coefficient, you eliminate it by multiplying by the reciprocal. One last type would be the division. If I start off with x divided by 3 equals 4, the inverse of division would be multiplication. I'll multiply both sides by 3. They cancel out on the left, and that leaves me 12. Let's see that again. X divided by 5 equals 10. Well, this is a division, so the inverse operation is multiplication. Multiplying will cancel out the x's, the 5's on the left, leaving me with x, and I multiply by 5 on the right, and that gives me 50. How do I know that's right? Well, let me divide. 50 divided by 5, it equals 10, and it checks. So once again, if we're looking at solving a one-step equation, we're going to look at the operation and perform the opposite to get the variable isolated. And that's all there is to one-step equations. You'll do some practice tonight.